Today we're going to review what a system of equation is and how to solve them. A system of equations is two or more equations with two or more variables used together. And to find the solution, what you're looking for is the one ordered pair that works in both of your equations, or all of your equations if there's more than two. There are three different ways we're going to look at to solve our systems: substitution, addition, and elimination. You want to choose the one that's the easiest or most efficient to use. So we're going to look at the differences between those. So the first one is substitution. We want to use substitution when we have one equation that's solved for a variable or can easily be solved for a variable. So for instance, on this one, we have y equals 2x plus 3. It's already solved for y. So what we can do is we can take and we can replace this y. We can trade it for what y is equal to. Every y we have is equal to a 2x plus 3. So we're going to replace this y in the second equation with a 2x plus 3. We keep everything else the same in our equation, except in place of the y, we put our 2x plus 3, and then we solve that equation. So we have 4x plus 6x plus 9 equals 29. And that gives us 10x equals 20, so x would equal 2. Once we know what x is, then we plug it back into here and we solve for y. So 2 times 2 plus 3 gives me 4 plus 3, which is 7. So our answer, our ordered pair, would be the ordered pair 2, 7. So it should work in both. 2 times 2 is 4 plus 3 makes 7. Down here, 4 times 2 is 8. Plus 3 times 7 is 21. 21 plus 8 does make 29. So our solution would be the ordered pair 2, 7. Our second method that we can use is what's called addition. And what you want to look for to use addition or subtraction is if we have the same coefficients on one of our variables, or we actually want them to be opposite coefficients. So if we look at our two equations, on this first one we have a positive 3y, and on the other one we have a negative 3y. So if we take those two equations and we literally add them together, the y's cancel out. So if I add the 5x and the 4x, that gives me 9x. 3y and negative 3y cancels out. And 13 plus 5 makes 18. So if 9x equals 18, then x equals 2. Then if we have to plug that back in, you can pick either of your two equations to find your other variable. So if we make 2x or 5 times 2, that would be 10 plus 3y equals 13, which means that y would equal, or 3y, sorry, would equal 3, so y would equal 1. So our solution this time is 2, 1. And then our third method is if we don't have the same or opposites, then we have to change them and make them so one of our coefficients is opposites. So here if I add the 5x and the 3x together, they don't cancel out. 4y and 5y don't cancel out. So what we're going to do is we're going to change these, kind of like finding a common denominator, and we're going to make two new equations that have opposite coefficients. You can decide which one you want to eliminate. I'm going to go ahead and eliminate my y's, which means I need to make those both into 20s. So I'm going to have to take this top equation and multiply it, everything in it by 5, and this bottom one we're going to multiply everything by 4. And that's going to create a negative 20y and a positive 20y. And then we're going to do it just like we did the other one. So if I multiply all this top equation by 5, that would give me 25x minus 20y equals negative 65. And if we do our second equation by 4, that gives me 12x positive 20y and 28. And then if we take those two and we add them together, we have 37x, and we have, let's see, negative 65 plus 28 would make negative 37, so x would then equal negative 1. And we have to plug it back into any of our equations that we have. I'm going to go ahead and use the 3x plus 5y. So 3 times my value for x is negative 1, that would give me negative 3x plus 5y equals 7. So 5y would then equal 10. So y would equal 2. So my ordered pair for this one would be -1, +2. So our three methods, we have substitution, when we have one that's solved for y, or that we could easily rearrange and solve for either x or y. It doesn't have to be y. Addition, if we have opposite coefficients on one of our variables. If they're exactly the same, then all you're going to do is change the signs on one so that when you add them together, they do cancel out. And the last one, if we can't use either of those two, we're going to create opposites and use our addition method. So we're going to multiply, and sometimes you only have to multiply one equation, sometimes you have to multiply two.